This is Chapter 4, Lesson 3, writing equations in point-slope form. So there are three different ways you can write a linear equation. You can write it in standard form, ax plus by equals c. We've gone over that previously. You can write it in slope-intercept form, kind of the most common that we work with, and that's y equals mx plus b. We went over that in lessons 4.1 and 4.2. And then there's point-slope form. And point-slope form, to me, is kind of like an in-between. We don't really use it by itself that often. It's kind of like a gateway way to write a linear equation. We can use it to then mathematically change it around. But we want to be familiar with what it is, what the parts of it are, identifying the parts of it, graphing it, things like that. So point-slope form of an equation looks like this. Y minus y1 equals m times x minus x1. Okay, and all that means is the only parts here that change are this y1, this m, and this x1. Everything else stays the same. So it's y minus a number equals the slope, like rise over run, just like we found in slope-intercept form, y minus y over x minus x, times x minus a number. This x and this y go together, and they represent a point on the line this equation's representing, right? Or this equation is, if we graphed it, this point, xy, would lie on the line of this graph. Okay, so basically we have a point on our line and the slope of our line, hence point slope, right? So we're gonna practice writing that a couple times. Here in this first little guy, I'll zoom in, we have write equation in point slope form for the line that passes through 6, 1. So that's a point on our line, and the slope of -5 over 2. So literally all we're doing is rewriting this equation, plugging these numbers in. There is no math involved, right? So I'm going to have y minus, and then what's the y value of the point on my line? 1. So I'm going to write y minus 1 equals the slope, which is -5 over 2, times x minus the x value of the point on my line, which is 6. And I'm done. I don't start simplifying. I don't do anything else. This is point slope form. The only thing that you might have to simplify is in the formula, we have minus signs here. So if this number happened to be a negative number, or if this number happened to be a negative number, then you would have y minus a negative number. So you might have to simplify the signs and it would become y plus whatever. If this was a -1, it would be y minus -1, which would simplify to y plus 1. But that would be the only thing you'd have to simplify. But once we're done, once we plug stuff in, this is point slope form. Y minus 1 equals -5 over 2 times x minus 6. We're done. That's our equation. And so if you're looking at a point slope equation, you know, okay, the number in front of parentheses is my slope, and then this second number here is my y value of my point on my line. This second number here is the x value of the point on my line. So the point on my line is 6, 1. There's a minus sign in the formula. That doesn't mean this number is negative. That means that there's a minus sign in the formula. So y minus a number, that number is 1. X minus a number, that number is 6. So the point here is 6, 1, and the slope is -5/2. Okay, we're gonna do it one more time. Got another one here. Write equation in point slope form for a horizontal line that passes through 4, -1. Now I will tell you that a horizontal line has a slope of 0. So we're gonna plug a 0 in for m there, and I'll go over that in just a minute. So we're gonna have y minus, and then the y value of my point on my line is -1, equals, for a horizontal line, the slope is 0, times x minus the x value of the point on my line, which is 4. Okay, and like I said, when you have a double negative here, you would have to simplify that, right? So you'd actually have y plus 1 equals 0 times x minus 4. Now, technically, this is point slope form, right? If we went ahead and simplified it once more, and we put y plus 1 equals 0, because it doesn't even matter what this is, because 0 times anything is just 0. Now we're starting to get out of point slope form, right? So you really want to keep it here. Even though it doesn't look like it's all the way simplified, it's still in point slope form. The number in front of parentheses is our slope, and the only type of line that has a 0 slope is a horizontal line, okay? Before we go any further with that, I do want to go over that real quick. So I wrote it out. I just wanted to kind of review it with you. Unzoom there. Okay, so whenever we graph a horizontal line, if you think about the slope of a horizontal line, horizontal means it's like the horizon. It goes side to side, right? If I were to find the slope of that line, remember the slope is rise over run. The change in y over the change in x, that little triangle means change, right? So how much am I going up and down over how much am I going side to side? Well, in a horizontal line, do we go up and down at all? No, we just go straight across. So we do move side to side. There is definitely a change here, right? So the change in x will be some kind of number. I don't know what the number is. It'll be some kind of number depending on what 2 points you use, right? Here it would be the difference in negative 2 and 3, so 5. But the change in y, the change up or down, there is no change. So the change is nothing, is 0. So in a horizontal line, there is no change up or down. There's no change in y, so there's 0. That goes on top of our fraction. So 0 divided by any number is just 0. So the slope of any horizontal line is always 0. So if something says, what's the slope of a horizontal line? Or use the slope of a horizontal line, blah, 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 it's always going to be 0. You don't have to know any details. Horizontal line, 0 slope, done. Okay? If we look at a vertical line, that's kind of similar, but kind of a different story in a way. There's like a little bit of an exception to this guy. Okay, so here is our vertical line. Same thing, the slope is the rise over the run, the change in y over change in x, change up and down over change side to side. Does a vertical line change up or down? Yeah, sure, to get from this dot to this dot, I gotta go up or down, right? Whether I'm going from here to here or here to here, I have to go up or down. So there's definitely a change in y, so it's something, depending on which 2 points I use on this line. What about side to side? Does my line change side to side at all? Does it go front or back? No, it just goes up or down. It doesn't go side to side at all. So the change side to side, the run, is 0. There is no change, right? And that's fine, and that is a fact, and this is a vertical line, and that's fine. However, in math, we don't have any such thing as a fraction with a 0 on the bottom. It's not possible. You can't leave a fraction with a 0 on the bottom. It doesn't exist, right? So the slope of a vertical line exists. Yes, it's a line. Yes, it has a slope. But that slope, we end up not being able to write that slope, because to write it correctly, we'd have to have a fraction with 0 on the bottom, and mathematically you can't. So therefore, the slope of a horizontal line can't be written, right? So to write that, I'm saying horizontal, the slope of a vertical line can't be written. So when we think of the slope of a vertical line, we say that it's undefined, right? It just means rise over run. The change in the run on the bottom of our fraction here is 0. And you can't have a fraction with 0 on the bottom, so we just aren't able to write anything. So we call that undefined. Okay, so it's the same kind of thing. The 0 just moves positions. In a horizontal line, the 0 is on top of the slope. In a vertical line, the 0 is on the bottom, but it makes a difference. 0 divided by anything is 0. Something divided by 0, you can't divide something by 0. You could divide it by 1, and then it's itself, right? If I have 1 pencil and only 1 person is using it, 1 pencil divided by 1 person, it's just 1, right? I can't divide by 0. There's no such thing. So vertical line, the way we write the slope, it's not possible. So we say it's undefined, okay? So hopefully that clarifies slope a little bit. You are going to see that some in this lesson and lessons moving forward. Okay, so we have write an equation in point slope form for the line that passes through each point with the given slope. Point slope is you just need 1 point on the line and the slope on the line, right? So again, I've got y minus y1 equals m times x minus x1. Here, m is 1, so that's going to go here. And y and x, my x1, y1, is 4 and 1, right? So x is 4, y is 1. So I'm going to write y minus 1 equals m, which is 1, times x minus 4. Don't put the number here for your point, don't put it first. Like this 1 never goes first. It's always written as y minus, it's a generic y minus your specific y, right? My specific y here is 1. So it always comes last. Same with the x's. Your specific x in your point on your line always goes last. Just a generic x, that first x, always stays in the front. And then, of course, the slope goes in front of our parentheses. So this is our point slope equation. Here, this is a horizontal line, and the slope of a horizontal line is 0. So we're going to write y minus y1. 2 is our y value, so y minus 2 equals 0 times x minus, and then our x value of our point is negative 3. And then, of course, whenever you have minus and negative, we turn it into a plus. When you're looking at a point slope form equation and you see a plus sign, you know that some of your values must be negative numbers, because in the formula in general, it's got minus signs in it, and the only thing that can change those minus signs to pluses are more minus signs. All right, and then number 3, y minus y1, here's our point on our line. The y value of that point is negative 3, equals m, the slope, our slope is negative 2, times x minus the x value of the point on my line, which is 2. And the only thing I need to simplify here is this minus negative 3 becomes plus 3, and I'm done. So those are point slope equations representing those lines. Okay, now it just gives me this information. So now I'm not looking at a graph, but I'm still going to write my point slope equation the same way. So I'm going to write y minus my y value here equals m, negative 1/2, times x minus my x value. And the only thing I need to simplify here is wherever I have a double minus sign, double negative, I change it to a plus. And I'm done. So y plus 5 equals negative 1/2 times x plus 4. Okay, here, y minus something equals m times x minus something. Y minus my y value is 7 equals m is 0 here, times x minus my x value, which is negative 6. And of course, I change a minus and negative to a plus. So y minus 7 equals 0 times x plus 6. And then finally, last one, y minus something equals m times x minus something else. Y minus my y value, here's my point, so my y value is 3, equals the slope, 1, times x minus the x value of my point, 8. And I don't have to simplify anything there, so I'm done. Once you start distributing and getting rid of parentheses and all that good stuff, then it's no longer in point slope form. So this is point slope form, just leave it. You plug in and you go. All right, 3 little exceptions here that we're going to wrap it all up, bring it all together. Number 9, 10, and 11, write an equation in point slope form for a horizontal line. Horizontal lines have a slope of 0. Same thing for this guy, slope of 0. And same thing for this guy, slope of 0. That passes through the point, this guy, right? So if we actually write that out for this first one, y minus my y value is negative 2 equals m, my slope for all 3 of these is 0, times x minus my x value, which is 4. And the only thing here I have to simplify is this double negative. I have to turn it into a plus. Okay, next one, y minus my y value, which is 6, equals, my slope is 0, times x minus my x value, which is -5. And the only thing I have to simplify here is that double minus sign. I have to change it to a plus. And when you rewrite it, you don't have to have this goofy looking plus sign. It just looks like that because I combined two minus signs. Okay, and then number 11, y equals, or sorry, not y, God, hello. Y minus my y value, which is 0, equals m, which is 0, times x minus my x value, which is 5. And of course, there's a lot of simplifying to do here, but once we start doing that, it's no longer in point slope form. So you leave it just like that. Okay, so then putting all three ways to write linear equations, putting them all together, they're on the bottom of these notes. So slope-intercept form is y equals mx plus b. M is the slope, b is the y-intercept. Hence, slope-intercept. Point-slope form is when we have the slope and then one point on our line. Now that point is x comma y and it gets separated, but that's okay. And then the third way, the one that we did the longest time ago, is standard form. ax plus by equals c. None of these letters mean anything. None of them are a slope. None of them are any kind of intercepts. They're just numbers. A, b, and c are just numbers, right? And then, of course, our variables x and y always stay in the equation. And remember, for standard form, the number in front of x, a, cannot be negative, and it cannot be a fraction. Cannot be negative, cannot be a fraction. Y can, the number in front of y can, b can be whatever it wants to be, but a can't be negative and it can't be a fraction. All right, almost done. Write each equation in standard form. So this gives you the point slope equation. We're going to rearrange it to put it in standard form. Standard form, remember, is ax plus by equals c. Basically, all you have to remember, because everyone gets confused with a, b, and c, is just x and y have to be on one side of the equal sign. Any other plain numbers have to be on the other side. That's standard form, right? So this is what we're going to use point slope form for the most, is first starting in point slope and then rearranging it to put it in either standard form or slope intercept. So here's our first one. Y plus 2 equals -3 times x minus 1. We have to get rid of those parentheses, so we distribute. -3x plus 3. And we're trying to get x and y on the same side of the equal sign. So I'm going to move x over here. Get rid of it on the right, move it to the left. So I'll have 3x plus y plus 2 equals 3 over here. So now I have x and y here. Great. I need all other numbers on this side. So I need to get rid of that plus 2. And whatever I do on one side of my equal sign, mathematically, I have to do it to the other to keep both sides equal. So I end up with 3x plus y equals 1. That's in standard form. ax plus by equals c. A would be 3, b would be 1, and c would be 1. Okay, next one, same thing. I got to put it in standard form, right? This negative sign here means that there's a -1 in front of our parentheses. So to get rid of parentheses, I need to distribute that -1. So I've got y plus 3 equals -1 times x is -x. Bring over my minus sign. -1 times 5 is -5. When I have a double minus, it becomes a plus. Okay, and I'm trying to get x and y on the same side of the equal sign, so I'm going to move this x over here. X plus y plus 3 equals 5. And I have x and y on one side, so I want to get all other numbers on the other side of my equal sign. 5 minus 3 is 2. So here, a would be 1. The number in front of x is 1. B would be 1. And c would be positive 2. Okay, and then finally, last one in standard form. Then we're going to do some points, slope-intercept form. Here, we want to distribute. Get rid of the parentheses, first step. Y plus 2 equals 2/3 times x is 2/3 x. Bring down my minus sign. 2/3 times 9. 2 times 9 is 18. and then I've got that 3 on the bottom of my fraction still. Okay, so once I simplify 18 divided by 3, that just becomes a 6. So I've got y plus 2 equals 2/3 x minus 6. I want to get x and y on one side of the equal sign, all other numbers on the other, so I'm going to move x. Negative 2/3 x plus y plus 2 equals negative 6. I want to move this negative 2, so I'm going to subtract 2 here. I got to subtract 2 here. These go away. Negative 2/3 x plus y equals negative 8. Am I done? No, because even though x and y are here, it looks like standard form, ax plus by equals c. A, the number in front of x, can't be negative and it can't be a fraction, right? So how do I make this number not negative and not a fraction? I'm going to multiply it by negative and by the denominator. Because if I multiply, the denominator is what it's being divided by. So if I multiply by that number, they cancel each other out, right? So I'm going to multiply everything, both sides of my equal sign, by negative 3. So negative 3 times negative 2/3 gives me positive 2, and that x stays with it. Negative 3 times positive y gives me negative 3y. Bring down my equal sign. Negative 3 times negative 8 gives me positive 24. So my equation, once I'm done simplifying, ends up being 2x minus 3y equals 24. Y can be negative, that's fine, but x can't be negative, the number in front of x. Okay, if you have questions on that, please let me know. That is actually very important that you understand that moving forward. We're going to use that a lot, and you also use it in geometry. So you do need to understand that. Don't skim over it or think, oh, well, I don't get it, whatever. Let me know, and I'll be happy to go over it with you. It's not a long process or anything. All right, lastly, 2 questions. Write each equation in slope-intercept form. Slope-intercept is y equals mx plus b. This is easy because we just have to get y by itself. So first we get rid of parentheses. Y plus 4 equals 4x minus 8. And then I want y by itself, so I get rid of 4. And I have to do the same thing here. Y equals 4x minus 12. Done. Y equals mx plus b. Done. The slope is 4. The y-intercept is negative 12. Here, same thing. I have to get rid of the parentheses. So y minus 5 equals 1/3 x. Bring down my minus sign. 1/3 times 6 is 6/3. 6/3 is just 2. All right, so now I want y by itself, so I'm going to add 5, and then I'm done. Y equals 1/3 x. Negative 2 plus 5 is 3. And this is y equals mx plus b, where the slope is 1/3 and the y-intercept is 3. They should be easy to identify. Let me know, please, please, please let me know, just privately or during a Q&A, whatever. Let me know if you have questions. I promise it doesn't have to be a long-winded thing for me to help you go over it. It can just be a real quick drawing I send you, or a practice problem to try, or a 2-minute video or something like that, but I want to make sure you understand it. All right, let me know.